Hi, Mike and Tony here. In episode 1 of the Robot Whisperers, we showed you the value of using 3D simulation software to create a 3D work cell layout.
Then we showed you how you can add kinematics to a work cell to create a 3D simulation.
This demonstrated how 3D can help you better utilize the space available in the work cell and use any CAD geometry to make things come alive and interact with other devices in the work cell.
We can help companies like yours significantly reduce the time and cost of putting a manufacturing system online.
You could call that the bottom line, Tony, because you can use simulation to validate the manufacturing system and the way it's supposed to work long before you invest in any man-hours or equipment in the production launch phase.
So stay tuned for episode 2 of the Robot Whisperers.
Hi, I'm Mike and this is Tony. Welcome back to the Robot Whisperers. On this episode, it's all about arc welding.
And we're on a mission to show you how you can use 3D simulation technology to design, validate, and offline program arc welding work cells.
That's right, we're going to tell you our top secrets on how to create auxiliary axis on a robot.
We're going to combine a virtual robot with a virtual gantry and part positioner. We're also going to show you how you can use the CAD geometry to create complex welding paths for the robot to follow.
You'll be able to create a lot of robot locations quickly and accurately, then arrange the work cell operations and simulate the production cycle.
Yeah, it's like you're the conductor, and the robots are all pieces in your orchestra, and you're conducting your work cell into a symphony of motion.
Where do you come up with this stuff, Tony? Well played.
Thanks, Mike. 3D simulation technology can help you choose the right model of robot, get the right robot placement, choose the right torch for the job, and help you configure it all so it works perfectly in perfect harmony.
And saving time and money is music to a manufacturer's ears. Hey, I get the whole symphony in motion now.
I thought you might. Robotic arc welding cells can have a gantry or a part positioner, and sometimes both, and this helps with the flexibility of the work cell. It also lets the robot create a variety of welds. Starting with a completed layout, the first thing to do is mount a robot to the gantry. We're using a robot from the robot library in the software. The software also gives you the capability to build your own robot. Our gantry is also from the library, but you could create that from your CAD data. The next step is to attach the torch to the faceplate of the robot. After the torch is built, we open it in the device builder. We're not ready to add kinematics, but we can add the tool point location, and this will be automatically input into the simulation for the robot's tool center point. After the robot has a defined tool center point, we add the part positioner, and we begin to create the weld paths for production. So, after we've added the torch to the faceplate of the robot, we then need to add the auxiliary axes. And we do this simply by picking the robot and then picking the gantry.
An auxiliary device can be located on the base of the robot like a gantry, on the floor like a part positioner, or it can be on the end of the robot like a weld gun.
Combining these devices allows each axis to be considered as part of the robot. All positional data of the robot and the auxiliary axes can be communicated to the robot on the floor using offline programming.
The work cell is now ready to create the robot paths. The simulation uses the available features in the CAD model to create them. There are several methods to do this. You can create a path on intersecting surfaces, on a curve, or on intersecting parts.
Here we will use the intersecting surfaces method. The software calculates the angle between the surfaces and bisects that angle to create a start and end point for the robot path.
You can also use the system to identify a sag value around a curve and apply that value to the curve with incredible accuracy. Sag value determines how closely the robot will follow the curve.
Once we've created the robot paths, we can go into the robot teach page and apply ingress and egress locations.
You know, Tony, another important feature of the software is that it allows the engineer to customize the way the system creates robot paths.
So if you create a lot of welds of the same style, it'll save you a tremendous amount of time when you're welding complex workpieces.
Absolutely. Tony, why don't we talk a little bit about some of the features and benefits that we've discussed so far?
Well, Mike, the software will create a lot of robot locations very quickly. Suppose you're working on a part that's very large. Say it's 4 feet across and you're using multiple weld passes. The software can save you an exorbitant amount of time to create welds that large, especially if we're welding on a curved part. Using the simulation with offline programming, you can weld as accurately as you need to, and you can easily modify the motion of the robot.
Those are all good points, Tony. Now let's look at what we call the Robot Teach page.
This lets the engineer add and delete robot locations, as well as modify the motion parameters of the robot path. You can insert via locations before or after each weld path for ingress and egress to the welds. This also is where we can dress the path with specific information for the robot to follow.
We can adjust the speed and accuracy of the robot program, as well as things like interpolation style, which affects the motion. The wrist configuration, tool point, and U-frame can also be changed easily in the program. It's a way that we can easily modify the robot motion and attributes. We do it all virtually.
Once the robot paths are created, we can start to program the gantry. And the gantry values can be calculated in 3 different ways. You can provide a constant offset value, and the system will calculate the gantry position to maintain that offset from the center of the robot to the robot location. You can enter a fixed value where the robot rail will maintain that position that you input. Or you can set the gantry to minimize motion. Here, the software will calculate the gantry value based on the minimum motion required to reach each robot location.
The ideal arc weld is as flat as possible. Molten metal flows with gravity, and the part positioner keeps the weld where it belongs. And there are several options when programming a part positioner values.
You can program them flat, vertical, or horizontal, or you can define the position. Once the system calculates the values, it will tell you if the welder can reach all the points in the path.
Tony, now that we've defined the robots and laid out the weld paths, why don't we tell them how we bring it all together?
Well, everything we've done so far leads up to work cell sequencing, and this is where the arrangements come in.
Now we'll arrange the order of the execution of the weld paths, because up to now, all we've done is place them. The next step is to choreograph the weld paths together.
We use a PERT chart to arrange the sequence of operation in either series or parallel. We rearrange the sequence by deleting and redrawing the arrows. It's that simple. Mike, tell them what it all means.
You saw how easy it is to program a rail and a positioner. That's already a huge time savings. But you can also use the same 3D environment to test multiple programming methods.
You can simulate different production scenarios to see the effects on work cell cycle time.
Now this really increases the engineering quality when developing a work cell.
You stole my thunder, Mike. But you know, there's still one more critical aspect that we need to cover.
What's that, Tony?
Now that everything's put together, we need to do some engineering studies on that work cell. One of the most important reasons to do a work cell simulation is to avoid collisions.
That can be real expensive. 3D simulation is also a valuable way to examine the physical relationship between the different objects in a work cell.
Like between the part and the end effector, or between the end effector and the tool fixture, or even between the product, the end effector, and the tool fixture all at the same time.
It's critical to make sure the simulation works perfectly before a business commits a single dime or man-hour to installation.
Well, that about wraps it up for this episode of the Robot Whisperers. And we hope you can see how quickly and easily you can program and validate arc welding work cells using 3D simulation.
And use 3D robotic simulation software to reduce time and cost when using robots in your production process, as well as reduce the overall risk when launching a production system.
Just like conducting a great symphony.
Thanks again for joining us. Join us next time when we discuss Robotology for spot welding. We'll see you there.